Hello everyone. So in this video we are going to discuss this question number 9 from paper 1 JEE Advanced 2026. I think this question is most talked about for last few days, and this question has multiple solutions also, and most of the solutions are proposed by going into the equivalence class and all. I was actually wondering why it is necessary, and suddenly I received a solution by one of my senior and friend Pankaj Sinha sir today morning. So in this video I'm going to propose his solution in my style and with some my input. So the solution is completely done by Pankaj Sinha sir. Full credit goes to him. So the question is, S is equal to 1 to 10 is a set given, and X is a collection of all the equivalence relation on the set S such that R has exactly 42 elements. So we need to construct equivalence relation, but this relation must have 42 elements. So we have to count such number of equivalence relations. So what we can see there, let's try to construct the equivalence relation from scratch. So to construct any equivalence relation, let's say R is an equivalence relation. So the first thing is we have to make it reflexive. So I will have 1, 1, 2, 2, all the way up to 10, 10. It means so far we have included 10 elements. If I have any 10 elements I have, and there is no such disturbance I have to give, because for reflexivity these 10 elements should be there, whatever equivalence relation you want to construct in. Now to construct symmetric, I have to have the image of feature like 1, 2. For that I must have 2, 1 and so on. And in total I need 42 elements. So let's try to construct a symmetric relation, and let's think how we can construct it. So suppose I took this 1, 2 there. So for that I need 2, 1. Suppose someone took 2, 3. I need 3, 2 as well, and so on. So basically in this construction, what is happening, try to visualize this thing. It is like I have this 1, 2, 3 up to 10 elements, and here also 1, 2. It is not necessary to do the diagonal thing or anything, matrix thing, but still you may understand better from here. So on this diagonal I have 1, 1, then 2, 2, then 3, 3, all the way up to 10, 10. What is happening over here, that suppose you are selecting 1 and 2, means 1, 2 is a pair made by this 1, let's say here, and this 2. So this is 1, 2. If you take this as first elements of any order pair, and this is second one. So 1, 2 is like there. So for that there is a 2, 1, then so on. So the idea is that if you are selecting 1, 2, you are forced to select 2, 1. It means there is no necessity to select the image of like across this diagonal. Suppose I'm selecting m elements out of here. So and m elements I'm going to do like this m square minus m. So this will give you this numbers. How we can understand? It's not difficult. Suppose you select 2 elements out of here. So 1 and 2 you selected. So 1 and 2 means from 1 and 2 you are taking 1 and 2 the cross product. So you get there 1, 1, 1, 2, 2, 2 and 2, 1. And in that already 1, 1 and 2, 2 you have actually included when you are creating the reflexive relation. It means you left out with only 1, 2 and 2, 1, which is needed there for symmetry. It means this idea will work for every such subset you want to construct. Let's say you constructed 1, 2, 3 or selected 1, 2, 3, same thing will work. 9 elements will be there total, out of which the 3 elements will be on the diagonal, which will be excluded. So in this way I have m square minus m. It means I claim or I propose or I guess. So guessing is that let's say m square minus m, total number should be 32. Then only the total numbers inside this set will be 42. So I have to find out the value of m so that it will fit. If it will not fit, then we will see what will happen. So what we can do now, let's say I'm taking 2 high. Let m be 2 high. 2 high means I'm suppose I'm taking all the elements like 1 to 10. So 10 elements I have taken. In that way, the m will be 10, let us say. So for m is equal to 10, this will not work actually. Why? Because this will give you 100 minus 10 on the left, which is very high compared to 32. Similarly, suppose I'm taking m is equal to 9, that will also not work. You can notice m is equal to 8 will also not work, and m is equal to 7 will also not work. What about m is equal to 6? Suppose I'm selecting m is equal to 6. Now the 2 high case is over. It is not working. So m is equal to 6 is working or not. Let's see. If I take m square minus m, that is going to be 6 square minus 6, which is nothing but 30. Now notice this came as 30 and I need total 32. It means now it's below that requirement. So I am left with 2 more elements to include. So this m square minus m is not a correct guess because these high numbers are not working, and when I go at 6, this is also very below, like not very below but still lower than the value 42 in total. So I go what I do now, this m square minus m is not working. It means I have to include some number of elements here. And how this number will be included? You notice that what you have done. You have selected in this case, for the case m is equal to 6, let's highlight it. So this case you have taken, and in this case what you have done, you got 30 and plus 10 for 40 elements more. I need 2 more elements. In this 6, suppose you have selected 1, 2, 3, 4, 5, 6. Suppose you have selected till 6 elements. And for this 1, 2, 3, 4, 5, 6, from there you got 30. But what about the 7, 8, 9, 10? 7, 8, 9, 10, suppose you have not chosen, but these 4 will again contribute to fill this 2 unit gap, means 2 numbers I need. So for that, for that what we need, I have to select only by the same way we have selected the 6 elements to construct 30 elements. I can select 2 more elements out of this 4 to get the total numbers completed. So this I need again by the same structure. So I can say the n square minus n. And this total is going to be now 2. And when this is total 2, it means n is going to be 2. You notice that this is the same structure we are doing. And so what we got here is, now I need m square minus m plus n square minus n is equal to 32. So the case 1, what I did, case 1 I have m is equal to 6 and n is equal to 2. Now, the problem is this is not the 30 and 2 you are going to count in such to find the number of elements in X. Try to visualize the scene, or try to go deeper. That the 30 elements, from where it is coming. Out of the 10, you have selected how much? 6. So this 10C6 is the number of ways. Let me write it. 10C6 is the number of ways to construct or to generate 30 elements. And again, this we have selected 2, n is 2, and 2 is coming from remaining 4 elements. So this 4 choose 2 is the number of ways to generate remaining 2 elements. It means there is a total number of ways to construct an equivalence class in such a way that m is equal to 6 and n is equal to 2. So in this case, I have, it means we are selecting like 10, 30 and 2. It's like this. So total number of ways in this first case. So case 1 total. So total case 1. I don't know whether the case 2 will be happen or not. I don't know. So let's see first. So what we get it here? 10C6 into 4 choose 2, and that you calculate, you get 1260 perhaps. So this is our first case. Now we go down. Suppose I have, since we have already constructed this structure there, this one, now I can see, like we go down to from 6 actually. So let's take m is equal to 5. If you take m is equal to 5, what I can take n? Let's see. By the way, yes, let's see what will happen. So if m is equal to 5, we get 25 minus 5, that is going to be 20. And n square minus n, 30. So I need n square minus n should be 12. It means I must have n is equal to 4. 16 minus 4 is 12. So n is equal to 4. Now how do we how we are doing this thing? In that scenario, the case 2, what is happening? Let's try to understand. In case 2, I have the equivalence relation like this: 1 1 up to 10 10. That is going to be reflexive. And then again we are doing 1 2, 2 1, and so on. But we are only selecting up to 5 elements. So 5 elements, let us say I've selected from 5 comma something to something comma 5, means 5 elements. So what is happening in this case, that for this I have selected 10, no problem, but this is going to be what, 5 square minus 5, that is going to be 20. And the remaining what I am getting, let's say a comma b, or b comma, and again b comma a, and so on. So these are going to be 12. So this 20 we are generating. This 20 we are generating from where? Out of 10, I am selecting 5. This 20 we are generating. How do we write it? Oh, let me see that. 10C6 the number of ways to generate. Yes. So 10C5 is the number of ways to generate this 20 elements. And again, this is actually 12 elements I have, and the remaining 5 elements what we had, because already we selected 5. So from 5 I am selecting 4. So 5 choose 4 is the number of ways to generate the remaining 12 elements. Should I write clearly, or maybe you're understanding? Number of ways to generate 12 elements. In this way, this 10 choose 5, the total number of ways in case 2, what we have is 10 choose 5 into 5 choose 4. So that is also 1260 if you count. And so the total of the total case 1 and case 2 is going to be 25, 20. So far, because I know the solution, that's why I did it. Why? Because suppose you want to take down for m is equal to, let's say, 4. For m is equal to 4, that is again the vice versa will happen. You notice that. For m is equal to 4, so n will become 5, because these are the pairs m is equal to 5 and 4. So that's why I told that without the loss of generality, because this is the same case you are doing basically. So m is equal to 4 is not required, or maybe already counted, so we don't want to double count. And if you go m is equal to 3, let's see what will happen. For m is equal to 3, I have this middle term 3 is a 9 minus 3, that is going to be 6, and 32 minus 6 is going to be n square minus n, and 32 minus 6 is going to be 26, and n square minus n is equal to 26. So can you find a natural number so that it will become n square minus n is 26? It means I need n and n minus 1 is equal to 26. I need two consecutive numbers whose product is 26. So in this way we cannot generate that. If you go lower, that n is equal to 2, again we cannot generate, and in other cases also, for higher already we have seen it. Therefore they are the only two cases possible, and we are getting this answer. So that's all for today. See you in the next video with some other interesting problem. Stay math active.